Hello, this is Andrew with WMH Racing, and today we are going to go over a new product that I am going to be releasing soon. This is still in its prototype stages, but a little bit about it. I had a request to build a battery discharger, mainly to allow for 1S discharging, but this will also work with 2S discharging. The 1S crowd does not have a standalone discharger for discharging their batteries and being able to compare them. Now, like I said, this is a prototype. I am not finished with this by any means. I still got a lot of work to do on the coding, and I still need to figure out what relevant data I need to display from running the discharging. I also, as you can see, I got a couple of MOSFETs just sticking up here. I had to add a couple of extra MOSFETs to the circuit because 2 were getting too hot. So I'm now running 4. And I'm probably going to up that a little bit along with adding a heat sink to these MOSFETs. But today we're just going to kind of do a bare bones test on this. So this discharger, it's very similar to what we would use in our iChargers. You're going to have an external resistor bank. You're going to have the discharger, and then this will be something like this. I'm not sure on the case yet, but something like this. I'm leaving this off for demonstration purposes because I'm actually going to have a temperature sensor connected to the MOSFETs to show temperature during this test. But in this LiPo safe, we have ourselves a 4100 milliamp 2S battery. Now, I'm going to put that back in the safe because I'm going to do this discharge test running at 40 amps. And just kind of a note on the discharge bank. So this discharge bank, as you can see, has 6 resistors instead of the standard 5. And that is to allow the 1S users to get down to a 45 amp discharge rate. The theoretical limit running a 2S would be over 100 amps. So it's pretty insane. You will be able to use this, however, with your current discharge banks that you have for 1S applications, unless you have one of the really old ones, and then it just won't be good enough. But the current discharge banks on the market would be able to dump a 1S battery at somewhere around 40 amps. But like I said, this one I had to create a bigger load in order for the 1S crowd to be able to dump their batteries at 45 amps. All right, so I'm going to zoom in on this a little bit, and I'm going to go over what we got. So I'm not done programming the menu on this either, and this is a touchscreen menu. So like I said, we're going to do a test, and we're going to see discharge current. And so I'm gonna run this current. We're going to do 40 amps, and then our cutoff voltage, we'll go down to 7.2, and then we get to the run discharge mode, and we're going to see that we got 8.3 volts is the current voltage of the battery. I mean, discharge amps at 0.05, so it's not really actually discharging yet. And the cutoff voltage is going to be 7.2. The rate's 40 amps. And then if I hit the run button, it'll start discharging. But the reason why I'm going to need to put heat sinks on these is because these things were actually getting pretty toasty. The first version with 2 MOSFETs, the MOSFETs actually unsoldered themselves from my circuit board. So it's kind of fun. So I'm going to use a PT100 temperature one. So this is a Platinum 100 temperature one, and it's hooked up to my Instax GOM 804 milliohm meter. So I'm just going to put this right here so we can get the temperature, and then you see right now we're at 22. You know, it'll bump up a little bit, somewhere around 24 degrees Celsius. I haven't. It's not actually running yet, but we're gonna go ahead and start this and see what happens, right? All right, so like I said, this touchscreen display programming, and it's controlled by a PWM with a PWM loop. A current sensor is giving feedback to the PWM, and then a microcontroller is going to be regulating the PWM duty cycle to maintain a whatever discharge current rate you set to use. So you're going to see that it does a little fluctuation right here between 39 and 39.8 and 40, or 39.6 and 40.2 amps. And we're gonna hit this. Yeah, it already dropped down to 7.2 volts. So a 40 amp discharge, you're putting a load on the battery. I mean, you can see that the voltage is going to bounce back. So a full discharge cycle, you would lower the cutoff voltage because we don't need this to bounce back all the way up to 8.06 volts. And actually, it's actually kind of good with this one because the MOSFETs only got up to about 80 degrees and they're already starting to cool back off. And this is Celsius, mind you. But in a longer cycle where it actually holds the discharge rate for a longer period of time, these MOSFETs were getting up, I think in about 2.5 minutes, they were getting up to about 120 degrees Celsius. So that's why I said I'm going to have to add a heat sink to this. And yeah, so I mean, there it is. Oh, to be honest, resistors didn't even get all that warm. Yeah, let's go ahead and drop that cutoff voltage down a little bit more. So it does 7 volts. See if we can pull it down a little bit more. So it does take a little bit to get up to the full discharge rate. And 40 amps is quite high. But like I said, the cutoff on this will be 45 amps. So look over here, we are 100 and climbing. We're still, so I'm gonna add readouts on here, like the number of milliamps that have actually gone out of the battery, your voltage time and levels and stuff like that. So we're gonna actually hit the We're at 125 degrees, and there we go, and it hit the cutoff too. All right, well, actually, we're still climbing a little bit. 134 degrees. And we're going to start going back down. Awesome. So that's a little bit warm for the MOSFETs. I mean, they can handle that temperature, but I'm definitely going to put a heat sink on them, and I might up the count to either 6 or 8 MOSFETs. So like I said, still quite a bit left to do on this project, but just kind of go over what is on the books, what is in the works for to be able to come out to you, and hopefully I'll have this ready in the first quarter of next year. All right, thanks for watching. Bye.